Okay, in this presentation we're going to look at directional derivatives, and so this is the first of a few examples. Find the directional derivative of the function f of x and y, where that's equal to x squared y plus x times y to the power of 4 at the point 1, 1 in the direction of the vector 3i plus 4j. First off, what we might do here is get the unit vector of that. So the absolute value, let's just call it A, is 3 squared plus 4 squared. That's equal to square root of 25. That's equal to 5. Okay, so the unit vector is 3 over 5 I plus 4 over 5 j. Essentially, divide each term by the absolute value there. That's what we're doing here. So that's the unit vector there. Now, what we're going to do now is we are going to, this is our function here again, f of xy. We are going to evaluate the gradient of f, and that is a vector comprised of the derivative of f with respect to x, plus the derivative, that's the I component, and the j component is the derivative of f with respect to y. So let's get both of those, the partial derivative even. So the partial derivative of f with respect to x is 2xy plus y to the power of 4. Okay. Partial derivative with respect to y is simply x squared plus 4 times xy cubed. Okay. Now what we're going to do is we are going to write out the gradient. The gradient of f is 2xy plus 4, or y to the power of 4 I plus x squared plus 4xy cubed j. Now remember what we have to evaluate it at the point 1, 1. Okay, so let's do that. Let's go back down here. So it is 2 times 1 times 1, that's simply 2, plus y to the power of 4, that's 1 to the power of 4, that's 1. 1 squared is 1, plus 4xy cubed, that's simply 4 times 1 times 1, so we just get 4. So the answer here is 3i plus 5j. Okay, now, good stuff. Now, we're ready to find the directional derivative. The directional derivative is d theta ds. Okay, and that is the product of the two. 3i, that's the gradient by the unit vector. So the gradient of f times by the unit vector, the product of the two, and we have 3 over 5i plus 4 over 5j. Now, what we're going to do here is multiply each of the components and then just add them up. So 3i plus 3 over 5. So that's the I components. That's 9 over 5. Now we'll do the j components. So it's 5 times 4 over 5. We'll just call that 20 over 5 for the time being. We'll just keep it sort of consistent with the 9 over 5. So 9 over 5 plus 20 over 5 is 29 over 5. You can make that 5 4/5 if you want, or 5.8 if you want. Alright, that's the directional derivative. That's one of our examples done. So let's leave that there and do a few more.